Apart from critical path method, precedence diagram is one of the preferable techniques used in project planning to determine the critical activities. Hi, I'm Dr. Siti. Today we are going to learn about precedence diagram. Precedence diagram uses the techniques of activity on node, where information about an activity is stated and described in the node. Now let's look at what are the basic elements of precedence diagram. Precedence diagram consists of nodes and error. Nodes represent the activities. For example, node A represent activity A while node B represent activity B. And line between these two activities represent the link from one activity to another. It represents with the line, width and arrowhead. And this is also represent the dependency between one activity to another. For precedence diagram, there is a predecessor and successor. Predecessor means that any activity that must be completed before a given activity can start. In this case, activity A is a predecessor of activity B. And successor means any activity that cannot start until a given activity has been complete. In this case, activity B is the successor of activity A. In labeling precedence activity, a node is been drawn in this manner. Usually, it is comprises of three parts in a node. The middle part, at the top of the middle part, it describes the activity, and the bottom part describes the duration of the activity. And it also describes the early start, early finish, late start and late finish for the activity. Similar like what we have learned last class, early start is how soon can the activity start. Early finish is how soon can the activity finish. Late start is how late can the activity start, while late finish is how late can the activity finish. In order to draw precedence diagram, there are a few fundamentals that you need to know. For example, the first one, if you have this network, activity A follows by activity B follows by activity C, it means that activity A is preceded by nothing. And activity B is preceded by activity A, while activity C is preceded by activity B. For this network, it means that activity B and activity C are preceded by activity A. And for this network, it means that activity A, B, and C can all begin at the same time. But ABC must complete first before activity D can start. Like I mentioned before, in order to make the network becomes more logical, there are four types of relationship that can be introduced in the network. The first one is finish to start relationship, starts to start relationship, finish to finish relationship, and start to finish relationship. Besides then the finish to start relationship, most commonly used are starts to start and finish to start, or in fact the combination of these two relationship. Now let's look at the first relationship, which is finish to start relationship, and this is the commonly used in precedence diagram. Okay, we have activity A followed by activity B. Activity Finish of activity A will determine the starts of activity B. And if there is a lag of 7 days described between the activity A and activity B, it says here that activity A complete first and it has to wait 7 days before activity B can start. Take for example, activity A is concreting and activity B is removing of the formwork. So in order to remove the formwork, we need to wait for 7 days before we can remove the formwork. That is why we put lag of 7 days, which is finish to start 7 days. So this is very important for the project manager to carefully check the lag time to reduce the risk of being late in the project. The second relationship is starts to start. This applies to schedule the start of successor activity, which is activity B, at the same time as for after some lag time to start for predecessor, which is activity A. So starts to starts means starts of activity A determine the starts of activity B. Take for example, activity A is pour concrete for slab, while activity B is level and smooth the concrete. Activity B cannot start until A has started, but should begin immediately after starts of A. Let's look at the second example of start to start relationship. In this case, we have P followed by Q. And in this case, we state that there is a relationship between P and Q by with the relationship of starts to start by 3 days. This means that activity Q cannot begin until 3 days after activity P begins. Okay, so let's look at the next example. For example, laying of pipes. You need to do the trench and you need to lay the pipe and you need to refill the trench. So in this case, between trench and lay pipe, the start to start relationship is 3 days. It means that once the trench activity starts, you need 3 days delay, then only the lay pipe can start. And for this activity, this link is also starts to start by 5 days. It means that once the lay of the pipe starts, it needs to wait for 5 days, then only the refill can start. Okay, the third relationship is finish to finish. Finish to finish means activity A completes, then only activity B can complete. Okay, let's look at the finish to finish example. For example, again, you have activity P followed by activity Q, and this time the relationship is finish to finish 3 days. This means that activity Q cannot be completed any earlier than 3 days after activity P completes. And in other words, the completion of activity Q is completion of activity B plus 3 days. And the date completion of activity Q will depend on the finish date of completion for activity B. Okay, let's look at this example. Example of testing of equipment. There is an installation activity followed by testing activity, and the relationship here is finish to finish 3 days. This relationship means that once the installation has complete, it has to wait for 3 days for the testing to complete. Or in other words, it says that the completion of testing has to wait for 3 days after the completion of installation. Okay, the last relationship is starts to finish relationship. Starts to finish relationship means that the finish of activity B depends on the starts of activity A. So let's look at this example. A followed by B, and the starts to finish is 3 days. So activity B here cannot end until 3 days after activity A has started. So in other words, the completion of activity B is the starts of activity A plus 3 days. For example, testing of concrete. This is the activity casting of concrete, and these are the testing to check on the quality of concrete. So the starts finish relationship is 3 days. It means that the completion of quality testing is where the starts of casting plus 3 days, then only the completion of the testing of quality can complete. The 4 types of relationship that I mentioned earlier used in precedence diagram is simply to make the network becomes more logical and more flexible and versatile compared to critical path method. Well, in critical path method, the logical relationship shows an activity must be completed before you can proceed with the following activity. And in critical path method uses only one relationship, which is the finish to start relationship. Now that we know the fundamental and the relationship of precedence diagram, let's look at the first example. In this case, we have three activities comprises of concrete work, which is 1 day, curing 3 days, and strip form work is another 1 day. So in CPM, critical path method, the activity is drawn in this manner, where activity A followed by activity B followed by activity C. But in precedence diagram, the activity is drawn in this way. Activity A, 1 day, followed by activity B, 3 days, and activity C, 1 day. In precedence diagram, besides then having to draw the network this way, you can also draw the network this way, where activity B can be eliminated and introduced by the relationship of finish start 3 days. Similar to critical path method, precedence diagram also uses the forward and backward pass calculation. Forward pass is to determine the early start and early finish, while backward pass is to determine the late start and late finish. Now let's look at the advantage of precedence diagram over critical path method. There is no use of dummy, ease of changing logic and adding additional activities. The planning could be done with less activities. So like I mentioned to you earlier, we can eliminate some of the activities and introduce the appropriate relationship. The code of activity number need not to be changed when logic was to be changed. Permits other relationships such as finish and start to start, whereby CPM only does finish start relationship. And also it allows for time lag quantities. Similar to critical path method, precedence diagram also consists of float. Let's look at the first float, which is total float. Total float is the total amount of time that a scheduled activity may be delayed or extended without delaying the project completion date. So this is similar to the calculation of total float in critical path method, where the formula is late start minus the early start, or late finish minus the early finish. For free float is the amount of time that a scheduled activity can be delayed without delaying the start of the next activity in the network. This is similar like what we have learned in the critical path method. And for free float calculation, there is no single formula to calculate the free float. Reason being that there are 4 relationships in the precedence diagram as compared to critical path method. So basically, it based on the lowest float of relationship with the successor. Okay, now let's try example 2. We have 9 activities altogether from activity A right up to activity I with the duration on the top here. And in these examples, we have 2 type of relationship, which is finish to start 6 days and starts to start in 10 days. And you need to calculate the using forward pass and backward pass to calculate the early start, early finish, late finish. And you need also to identify which are the critical paths and calculate the float for each of the activity. Let's do this example together. In order to determine the early start, early finish, late start, late finish, we need to conduct the forward pass and backward pass. So let's do the forward pass first. As you know, forward pass is from the left side of the diagram to the right side of the diagram, and you need to plus the duration. We start the activity A with 0. 0 plus the duration is 8. 8 for activity B, early start for activity B plus 12 is 20. 20 plus 14 is 34. 34 plus 8 is 42. Okay, so we stop there first because as you see, in order to determine the early start for activity I, there is 3 arrow coming into activity I. So let's continue with activity C. So activity C takes the same value as early finish of activity A, which is 8 plus 16, 24. 24 plus 13 is 37. And in order for you to determine the early start for activity H, you need to see there is 2 arrow coming into this node. One arrow is from activity D and another arrow is from activity E. So the first arrow, which is from activity D, is 34, while from activity E is 37. Like I mentioned to you earlier, when the forward pass, you take the larger number. So in this case, the larger number is 37. So early start for activity H is 37. 37 plus 14 is 51. Okay, we stop there first. We continue with activity F. Okay, for activity F, as you can see here, there is a relationship of starts to start with 10 days. Okay, in order to determine what is the early start for activity F, you need to look the starts of activity C. So activity C is 8 here. 8 plus 10, you can determine the early start of activity F. And activity F is 8 plus 10 is 18. 18 plus 19 is 37. Alright, now we can find what is the early start for activity I. Between activity G and activity I, there is a relationship, finish to start relationship of 6 days. So you need to include this relationship where you need to add 42 plus 6 is 48. And from activity H, 51, and from activity F is 37. Like I mentioned here earlier, you take the larger number and the larger number is 51. So 51 plus 12 is 63. So it shows here that the project completes in 63 days. So now let's continue with the backward pass. Backward pass, similarly like in critical path method, the backward pass starts from the right side of the diagram to the left side of the diagram, and you need to minus the duration. So let's start with 63 days. 63 minus 12 is 51. So you can put 51 here. 51 minus 14 is 37. And in order for you to determine this value, you need to consider finish to start relationship also. So 51, instead of plus, you need to minus them. 51 minus 6 will be 45. 45 minus 8 is 37. And in order to get this, you must make sure to see, please bear in mind that there is two arrow coming into this box. So from activity G and activity H. So both activity has the same value, which is 37. So that is why I put here 37. 37 minus 14 is 23. 23 minus 12 is 11. Okay, let's hold the calculation at this point. We continue and at activity I. Again, activity I to activity F is 51 and minus 19 is 32. Okay, for activity E, this is 37. So 37 minus 13 is 24. 24. In order to determine this value, you need to consider from two different direction. The first one is from E, which is 24. 24 minus 16, or you need also to consider the starts to start relationship here. So the first one is 24 minus by the 16, and another one is 32 minus with 10. So again, we need to, similar like critical path method, you need to take the smaller number. In this case, the smaller number is 8. So 8 and 11. So you need to take the smaller number, which is 8, and it goes back to 0. So in order for you to make sure that your calculation is correct, the value here must goes back to the same value where you start. Next, we need to determine which is the critical activities for us to determine the critical path. So similarly like critical path method, in order to determine the critical activity, the total float must be 0. The total float is calculated as late start minus early start, or late finish minus early finish. So in this case, the total float is 0 for the activity which is marked in yellow color. So for this activity, the total float is 0. And for activity B, the float is 3, T is 3, G is 3, and for activity F, the float is 14. Now that we have gone through together to solve the example 2 problem, why not you try example 3? Example 3 is very similar to example 2, but in this case we have only one relationship, which is finish to start 2 days. And you can calculate what are the early start, early finish, late start, late finish, and also identify which are the critical paths. If you want to challenge yourself, you can proceed with example 4. Example 4 is quite complicated, where there is few relationship introduced in this entire network. Okay, if I'm not mistaken, there is 5 relationship. So you can try to calculate what are the early start, early finish, late start, late finish by incorporating the relationship into your calculation and find what are the project duration for the example 4. Okay, so have it a go, and I think that's all for today, and I'll see you next week. Okay, so stay safe. Bye bye. Assalamualaikum.